Good day, everybody. How are you all doing? Today we are going to talk about binomial distribution. So here I go. Bi, as the name implies, or as the prefix implies, it means two. Binomial means two possible outcomes in a probability experiment. Okay. Determine whether a random variable is binomial. Your favorite restaurant is giving away a coupon with every purchase of a meal. 20% of the coupons entitle you to a free milkshake, and the rest of them say better luck next time. Suppose that 10 of you order lunch at this restaurant. What is the probability that 3 of you order a milkshake? This is not a straightforward probability. Its value depends on the fact that there are different ways to get three winners from a group of 10. In general, if we let X be the number of people out of 10 that win a milkshake, we will learn that X is the number of people out of 10 who win a free milkshake. We will learn that X has a distribution called a binomial distribution, which is one of the most useful probability distribution. In this example just describes, each time we examine a coupon, we call a trial. So there are 10 trials because there are 10 people. When a coupon is good for a free milkshake, we call it success. The random variable X represents the number of successes in 10 trials. A random variable that represents the number of successes in a series of trials has a probability distribution called the binomial distribution. The conditions, a fixed number of trials are conducted, in this case 10. There are two possible outcomes for each trial. One is labeled success, get a free milkshake, and the other is labeled failure, better luck next time. The probability of success is the same on each trial. Remember, in this problem, 20% of the coupons are printed with free milkshake. So probability of success in that case is 0.2. The trials are independent. That means the outcome of one trial or the result of one trial does not affect the results of the other trials. The random variable X represents the number of successes that occur. Decide in case whether X is a binomial random variable. A coin is tossed 10 times. Let X be the number of times the coin lands head. This is a binomial experiment. Each toss of the coin is a trial. There are two possible outcomes, either a head or a tail. Since X represents the number of heads, heads counts as success. The trials are independent. 5 basketball players each attempt a free throw. Let X be the number of free throws made. This is not a binomial experiment. Why? Because probability of success or making a shot differs from player to player. 10 cards are in a box. 5 are red and 5 are green. 3 of the cards are drawn at random. Let X be the number of red cards drawn. This is not a binomial experiment because the trials are not independent. Why? Why the trials are not independent? Each time you're taking out a card, if you take out a red card and leave it aside, then the number of red cards get affected, right? Because initially you had 5 red cards. Now, if you take out a card and by chance it is red and you leave it aside, then inside the jar you will have, or in a box, you will have 4 red cards now. So that's why they're saying, because now the number of cards, total number of cards is 9 instead of 10. So this is not a binomial experiment because the trials are not independent. Why? Because what you draw in the first trial will influence what you draw in the second trial, or the probability of the second trial. Okay. Decide in each case whether X is a binomial random variable. A fair dice costs 20 times. Let X be the number of times die comes up 6. Okay. So either it comes up with a 6 or not a 6. And probability is constant, 1 out of 6. Hence, this is a binomial experiment. Standard deck of cards, 52 cards, contain 4 S's. 4 cards are dealt without replacement from this deck. Again, this is not a binomial probability distribution. Let X be the number of cards that are aces. Why? Because every time you draw a card and leave it aside, you are affecting how many cards are left, and hence the probability of success is varying from trial to trial. A simple random sample of 50 voters is drawn from the residents in a large city. Let X be the number who plan to vote for a proposition to increase spending on public schools. Okay. X be the number of people. Okay. And a random sample of 50. So X value can vary all the way from 0 to 50. Okay. Proposition, a number of people. Will the probability be the same? Probably not. There will be the number of people who plan to vote for proposal. We do not know whether how much each person is motivated to vote to increase. So bottom line, the probability is changing from person to person. So this is not a binomial distribution. Okay. Determine the probability distribution of a binomial random variable. Okay. Consider a binomial experiment of tossing 3 times a biased coin that has probability of 0.6 of coming up with heads. Let X be the number of heads that comes up. If we want to compute probability of 2 heads, the probability that exactly 2 of the tosses are heads, there are 3 arrangements of the 2 heads, okay? And in the 3 tosses, HHT or HTH or THH. The probability of HTT is probability of HHT is 0.6 times 0.6, okay, times, because it came up with one tail, is 0.4, is 0.6 square times 0.4. Similarly, we find the probability of head tail H is same as probability of tail head head is 0.6 square times 0.4. Now, probability of P2 is probability head head tail or head tail head or head tail head head. So it is 3, okay, 3 times 0.6 square times 0.4 by the general addition rule, okay. Why 0.3? Because each of these probabilities are same and it is 0.6 square times 0.4, okay. Yeah, so now P times 2 is this by the general addition rule. Examining this result, we see the number of 3. Number 3 represents the number of arrangements of 2 successes, heads, and 1 failure. In general, this number will be the number of arrangements of X successes in N trials, which is combination of X taken out of N without regards to order. Okay, the number 0.6 is the success probability for P, which has an exponent of 2, the number of success X, which is 2. And number 0.4 is the failure probability 1 minus P, which has an exponent of 1, which is the number of failures N minus X. Okay. So probability of 2, let me go over that. 2 means 2 heads, and it can occur in 3 ways, HHT or HTH or THH. Probability of each of them is 0.6 because head is twice 0.6 square times tail probability is 0.4. So each of them, and now there are 3 possibilities. So that's why it is 3 times 0.6 square times 4. Now 3, they are indicating that it is the combination of X items, in this case, 2 items taken out of 3. And what is number 6 is the probability of success. And what is 0.4? It is 1 minus P. Now, probability of success is raised to the power of 2. That is the number of successes. And 0.4 is raised to the power of 1, which is total number of trials is 3. 3 minus 2, 1. Okay. So the final formula becomes for a binomial random variable X that represents the number of successes in N trials with success probability P, the probability of X success is probability of X, NCX means probability, a combination, number of ways in which you can take X items out of N without regards to order, multiplied by probability of success raised to the power of success, which is X, multiplied by probability of failure, which is 1 minus phi, raised to the power of N, which is the total number of trials, minus X, success. And the possible values of the random variable X are 0 through N. So we are not going to use the formula, we are going to use the calculator. So I will just directly go to the calculator. In the TI-84 calculator, there are two commands for the computing binomial probabilities. These are binom PDF and binom CDF. These commands are under the distribution. This is second verse, and then you select either binom PDF or binom CDF. The binom PDF command is used when finding the probability that the binomial random variable X is equal to a specific value. That is important. PDF when X is equal to a specific value. And then what is binom CDF? Binom CDF C stands for cumulative. The binom CDF command is used when finding the probability binom random variable is less than or equal to a specified value X. What does it mean? Suppose I want to find out binom CDF 4. That means I want X to be less than equal to 4. So it can be 0, 1, 2, 3, and 4. Bottom line, when I use C, I add from 0 probability value, X 0 probability value, to X is equal to the specific value. So C is cumulative. Take all the values before that number, get probabilities, and add them together starting from 0. Binom PDF to compute the probability random variable X equals to value X given parameters N and P. Use the binom PDF command for a particular value of X. Binom CDF is to compute the probability that the random variable X is less than equal to. Less than equal to means suppose X is less than equal to 2. That means 0, 1, and 2. Cumulative C. You start from 0, add up to that number, the probability values equal to the values given by the parameters n and p. N is number of trials, p is probability of success, etc. So let's do this problem using our calculator. The Pew Research Center recently reported that approximately 30% of internet users in the United States use the image sharing website Pinterest. Suppose a simple random sample of 15, n equal to 15 internet users is taken. Use the binomial probability distribution to find the following probabilities. Now, a point to note, second line, Pew Research Center recently reported that approximately 30% the probability of success P, small p, is 0.3. We always convert it to decimal. Exactly 4. How do you do exactly 4? So second verse in the third line. Then scroll down to binom PDF. Okay, and hit enter. Number of trials is 15. Probability of success is 0.3, and you want to find out the probability value at exactly 4. So X value is 4. Okay. And you paste, enter, and enter. And that probability is 0.2186. Okay. What is the next one? Probability that fewer than 3. Fewer than 3 means 0, 1, and 2. So you're picking the probability of X equal to 0 and adding it to X equal to 1, adding it to X equal to 2. Since we start from 0 up to 2, this is binom CDF. Second verse, you scroll down to binom CDF and hit enter. Number of trials is 15. P value is 0.3. And you want fewer than 3. That means it's 0, 1, and 2. So the last number starting from 0 you're going to add is up to 2. That will be the X value. 2, paste, enter, and enter. And the answer is 0.1268. Okay. Then the next one is probability that one person, more than one. More than one means you're not interested in 0 and 1. So that is the complement of more than 1. More than 1 means start from 2. Definitely you are not interested in 0 and 1. This is the complement. So we are going to use the complement rule of probability. So probability of X greater than 1 is equal to 1 minus binom CDF N, P, and X, where X is 1. Binom CDF, because we'll add 0 and 1. So how do I do this? I press 1 minus second verse. and we scroll down to binom CDF. Because I'm not interested in 0 and 1, I'm removing those. Those are the complement event. 1 minus, scroll down to second verse, binom CDF. Number of trials is 15, probability is 0.3, and I'm adding 0 and 1. So my x value, last x value is 1. Paste, enter, and enter. And the answer is 0.9647. Yep. Okay. And the last one, find the probability that number of people who use the Pinterest is between 1 and 4. So I can do it two ways. I can find from 0 to 4 cumulative probability, CDF, and then remove probability value of x0 because I'm interested in 1, 2, 3, and 4. So first find 0 to 4. From that, subtract binom for just x is 0 because then you'll be left with 1, 2, 3, and 4. So second verse, binom CDF, number of trials is 15, p is 0.3. You're adding from 0 to 4 first, then val paste and hit enter only once. Okay. Minus, you're going to remove the binom for 0, the probability value for 0, because that will leave us 1, 2, 3, and 4. So minus second verse, you go to binom PDF and hit number of trials 15, probability of success is 0.3, and I just want to remove x value 0. And paste, enter, and enter. And the answer is 0.510, 0.5107, or 0.511. Okay. We're not interested in Excel, so we'll skip this. The same thing, we will not do it again. Compute the mean and variance of a binomial random variable. Mean and a variance. Mean and variance. Mean is given by this formula, mu is equal to n times p. That means number of trials times probability of success. Variance is given by n times 1 p, probability of success, times 1 minus p, which is probability of failure. So to get the standard deviation, we'll take the square root of the variance. So let me see if there is. Okay. Gregor Mendel discovered basic laws of heredity by studying pea plants. In one experiment, he produced plants whose parent plants genes for both green and yellow pods. Mendel's theory states that offspring of two such parents has probability of 0.7 of having green pods. Assume that 80 such plants. So P is 0.75. Your sample number of trials, N is 80 sample size. Find the mean. So the mean is 80 multiplied by 0.75. So on the average, 60 out of 80 will have green pods. 60 plants out of 80 plants. Variance. So you multiply 80 times 0.75, then left parenthesis 1 minus 0.75, which is the probability of failure. That's your variance. Okay. So your variance is 15. Now to find the standard deviation, you do second, and then x squared gives you the square root. Inside the square root, type in 15 and enter. So standard deviation is 3.873. Remember, first we find the variance and then take the square root to get the standard deviation. Okay. Okay, that's it for today. I'm going to stop here. If you want to make a comment, please go ahead and do it. I appreciate that. Please give me a thumbs up if you really like this video. I really appreciate that. And if you like this video, share with your friends, you and your friends. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner and hit the bell, which will notify YouTube that you'd like to be notified every time I upload a new video, which I do almost every day. And please check out my channel where I've solved all kinds of problems just for you. Thanks for watching, you and your friends. Please subscribe to my channel by hitting the red subscribe button. Thanks for watching, and do not forget to watch me tomorrow when I'll come back with another interesting video. Thanks for watching. Take care. Have a nice day.